In this concept video, we're going to be discussing how to convert between exponential and logarithmic equations, and then also we'll talk a little bit about common logarithms and natural logarithms. So we're going to start with an exponential equation. I'll give you 7 to the x power, and we're going to make that equal to 49. So I know a lot of you out there are saying to yourself, well, x is 2. And that's wonderful when it works out like that. In this case it does, but there's going to be some other cases where it doesn't. So we need to develop a system or some kind of notation to be able to solve for this variable up here. Before, the variable was in the base position, and then, if you had a 2 or something like that up there, you could just take the square root of each side and that would be fine. And those are inverse operations. Turns out, though, for an exponential equation, that doesn't really work. I mean, how are you supposed to take the x root of each side? That wouldn't work very well. You still wouldn't be solving for x. So there's a different notation, and that's another inverse here. It's the inverse of an exponential, which is where the variable is in the exponent position, and the inverse is a logarithm. Okay, logarithms are exponents, they're just inverses, and so the rules are similar, and all we need to do here is write some different notation. We're going to write log. The base is 7. The base is going to go in this little subscript position. And then the next position here, we're going to be solving for the x. So the 49, which is called the argument, that's going to be in the next position in our logarithmic equation. And on the right-hand side here, we've got what we're solving for, which is x. And it turns out that you can actually type this one into your calculator and you can solve for x. Great when it works out like this. You know it's 2. 7 squared is equal to 49, but let's say this number was something else. Let's say it was 40. It would be really difficult to find a good answer here for x because that value is not going to be a rational number. And so this notation allows us to find a more precise value using logarithms. So if we look at where these values are, remember that for a logarithm, we're always solving for the variable. The base, which starts with a b, goes down below in logarithmic form on the right-hand side here. And then the 49, which we call the argument, is going to slide over, and that's going to move to the left side of the equal sign. So the x and this 49 kind of trade sides of the equal sign, if you want to think about it like that. So just remember that the base always goes below in logarithmic, in a logarithmic form, and we're always solving for the x. The other number, which is called the argument, then would go in the missing space right here. If we try this with a different equation without any numbers, here's what it's going to look like. Oops, let's scratch that. Let me write b, and then I'll try to use the same colors here. B to the x, and that's going to be equal to, let's say, some value c. Then in logarithmic form, we can write log of the base, which is b, and it's a little bit smaller. The base over here is big, and in log form we kind of write that a little bit smaller in the subscript position. And then remember that we're solving for the exponent up here, x. So that x goes there. Where does the c go? Well, it goes in the missing spot here. And remember, the c is called the argument. It's going to go right there. So the same thing applies. The c will come over and just be right there next to the log. The base is down below in logarithmic form. And then remember, we're always solving for the exponent. Important key concept. Exponents and logarithms are inverses, and logarithms are really exponents, just kind of in disguise. Let's talk about common logarithms and natural logarithms. So this is just a vocabulary item, and a common logarithm has a base of 10. That's what the word common means. It's common because that's what our number base system is in. It's in 10, so we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then instead of having a new character for 10, we write actually a 1 and a 0. So we have a base 10 number system, which is why it's common. Natural logarithms, on the other hand, have a base of e. And we call them natural because we use natural logarithms and e a lot in the sciences, like biology, counting populations and things like that. So it appears in a lot of natural or out in the world kind of situations, out in nature, I guess. So let's take a look at an example for a common logarithm, which is a log of base 10, and kind of like some other things in mathematics. We don't write any base of 10. Kind of like if you have a square root, you don't write the 2 on the ledge, you just leave it off. Or if you have 1 times x, you don't write the 1, you just write x. So a common logarithm, if you don't see a little base down here, it's definitely 10. And so let me write this for you. Log of 1000 equals 3, which is really log base 10 of 1000. So again, if it's missing, it's 10. And that's 3. And is this true? So the base is 10, the exponent is 3, and then the argument, or the value here on the right hand side, is 1000. And 10 to the third is 1000. So we're good there. This actually was a valid equation at the very top here. The log of 1000 is equal to 3. There's no base. It's definitely a common logarithm. The base is 10. We just don't write it. Let's take a look here at a natural log, and I'll write this for you. I'll write the natural log of 7 is equal to x. So now we have a variable in there. Oh no. And a natural log is written ln. When it's written ln, it means natural logs. You can or a logarithm that's natural, I guess, if you want to say that. And if you wrote this out a little bit, it would be log base e. Everything else stays the same. The reason why we don't write this log base e is because it's a little bit easier to just write ln and then continue on. Same thing over here. When there's no base, it's just understood to be base 10. So this one would be e to the x is equal to 7 in exponent form. The base is e, the exponent is x, and that's 7. And you could actually type this into your calculator and figure out what exponent would go up here. And that's one of the nice things about logarithms is we can now solve for a variable in the exponent position.